Let's take a moment and thank our sponsor, Text Control. There's always something new from Text Control. As a developer, do you need to integrate PDF generation, document editing, or electronic signatures into your ASP.NET Core or Angular applications? Or maybe you want to learn more about the differences between electronic and digital signatures. Text Control is offering a free consulting service to educate you about digital document processing and how Text Control products can help you add these features to your applications. You just go to textcontrol.com/contact and you can request your free personal consultation. How cool is that? Textcontrol.com/contact and you can request a free personal consultation from our friends at Text Control. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Dr. Gregory Kapfhammer, an associate professor of computer science at Allegheny College. How are you?
Hey, I'm doing great, Scott. Thanks for welcoming me to the podcast. I really appreciate it.
Yeah, so I want to talk to you about some cool research that you're doing. I'll put links in the show notes and people can check you out at gregorykapfhammer.com. But you've got a paper out on flaky tests. And I believe that you did that with one of your PhD students, your research students?
Yeah, that's correct. So I was really excited to work on a collaborative research project with a PhD student whose first name is Owen, and additionally to work with two research colleagues, Michael, who is a professor at CMU, and my colleague Phil, who's a professor at the University of Sheffield. We've been focusing our research on finding, detecting, and repairing flaky test cases.
Okay, so flaky does not sound like a PhD level, high level research word. It seems like the kind of thing that I would just casually, I got the flaky test, these darn flaky tests. But is there a definition? Is there a decided upon definition for what makes something flaky?
Yeah, that's a really good question. It may not be the case that there's 100% consensus on what I'm about to say, but I would argue that most developers agree that flaky test cases are those test cases that can pass or fail without changes to the source code of the program under test. Because of the fact that they're flaky, they often tend to hinder development in continuous integration environments, and they also lead to giving a poor signal about the correctness of the program under test.
Interesting. Okay, so when I think about why I test, what the actual reason for the test is, if you're a business person, you might say, well, it's for confidence in the system. But for me, it's so that I'm not afraid. I feel like the more tests I have, the less fear I have of the system, and that lack of fear then allows me to do effective CI/CD and effective refactoring. And the more tests, the more aggressively or the more assertively I can go and refactor. But a flaky test is going to make me lose confidence. I'm going to be more afraid. It's going to undo all of my hard work.
Yeah, I think what you're saying is precisely right. So in my view, there's two losses of confidence. First of all, there could be a loss in the confidence of the correctness of the system under test. And then additionally, there's a lack in confidence in terms of the way that you might refactor the system or add features to the system or maybe introduce bug fixes to the system. So in all of those situations, if test cases are flaky, they make our job as developers much more difficult.
Mm-hmm. And is it fair to say that if a test is flaky, that I might just stop listening to it? It's kind of like Chicken Little, who's saying that the sky is falling, and then you say, that test has been flaky since the early 90s. No one cares about that test. So when it really actually does fail properly, I'm going to say, well, that thing's always flaky and ignore it.
Yeah, you're exactly right. We've actually done some surveys of developers, and one of the things that they told us is test cases ultimately, when they are flaky, lead to serious problems in the correctness of their system because the flaky test cases tend to get ignored. And when they're ignored, they may be deleted, they may be quarantined, or they may never be repaired and they just continue to cast doubt on the execution of the test suite. So in all of those cases, developer velocity and productivity goes down, and bugs are more likely to creep into the system.
Interesting. And I've actually seen test frameworks build features to like repeat tests to get around them. So, like, just do a retry, which I don't feel like is something we should be doing in a test framework, or just, ignore it. And then it becomes a to do that is technical debt that will never be repaired.
Yeah, that's right. I think that there are some benefits to rerunning test cases multiple times.
Hmm.
So, for example, there's a surefire plugin for the Maven build system, and it will run your test cases multiple times and try to accrue evidence as to whether or not the flakiness in your JUnit test suite is a serious problem. There's also plugins for PyTest, a popular testing framework for Python, and those also allow you to rerun your test cases. I do think there's value, but you're right, rerunning isn't a panacea because there's still likely some problem with either the test case or the program under test that hasn't been fully diagnosed and resolved.
That makes sense. Yeah, iterating and redoing tests or running tests multiple n times has value, but just retrying until it succeeds is putting a band-aid on cancer.
Yeah, the other point that I would share is that there's one kind of flaky test case, or I would say a category of flaky test cases that are called order dependent flaky test cases. So those test cases tend to become flaky if they're not run in an order that meets the assumptions of the tester. So, in my experience as a developer, I actually appreciate the opportunity to do rerunning if I rerun in a different context than the test suite is normally run in, because that might give me some insights into the source of the test flakiness and then give me a shot at actually repairing the problem and fixing it and eradicating the flakiness from that test.
But when is having order dependence important? And and it's not that it's a flaky test; it's that you ran it in the wrong order. Like, should I, or is it a poorly designed test system that requires a unit test, using unit testing as the example, to be, atomic?
Yeah, so your point is a really good one. A lot of people debate about whether or not test cases should ever have any dependencies in them at all. There are some cases, especially if you're dealing with an integration test, where there might be some dependencies that you want to leave in between test cases because the setup and teardown process is super expensive. And so you're going to accept some of those dependencies. However, in my case, when I'm writing unit test cases, I try to make my test cases as independent as is possible so that I can avoid order dependence and flakiness creeping into my system. Finally, it's worth noting that there are some testing frameworks like TestNG that allow you to explicitly test and express dependencies in the test suite. And then you might be able to avoid some flakiness if the test suite is rerun in a different order.
Hmm. I was doing unit testing early on when we were still trying to figure out what the name for these things were going to be during the extreme programming years. And this is, of course, a long time before the formalization of containers, but we always were told to think about it like it was an atomic little world. So we would have a, very complicated setup and very complicated tear down test runs, so that each individual test had a big old setup and a big old teardown, almost as if it were running in a container. But sometimes we would leave a little schmutz around. I don't know if that's a technical word, but then again, we decided that flaky is a PhD level word. So leaving a little extra schmutz around, maybe a piece of state or a file or something. Are flaky tests affected by detritus that may have been left somewhere on the in the file system?
Yeah, you're making a really good point, Scott. One of the types of testing that I've done frequently is testing programs that interact with something like a relational database. And when I'm testing in those situations, I am sometimes tempted to leave some state in the relational database because it allows the test cases to execute faster. However, shared state when it wasn't intended could ultimately lead to problems during testing, which are manifested as flaky test cases.
Interesting. That makes me feel like after after we would do these tests with these setups and these teardowns, we would say, "Wow, this is taking an hour." If we would just do the setup at the beginning, these tests would run in minutes. So we would kind of over optimize, and in doing that, create flakies. But I don't think we would ever know until it became a flaky. We were actually invalidating our test cases because, they say that it's not a test unless you've seen it fail at least once.
Yeah, I absolutely know what you're getting at. I have also, in certain situations, left some state in the database because I wanted my test suite to run faster. And so I think you're hitting on a good point, which is that there's often a trade off between the efficiency of the testing process and then the quality of the signal that the test suite can share with you as a developer.
Yeah, and I'm thinking about ways to get around it. We now have containers, so largely we could use containers for setup and tear down. But now we're going to start paying more for the compute for these things. And when you're talking about tens of thousands of tests, you might end up with a test suite that's going to run a very long time. But this brings me to my next question. Let's talk about the difference between unit tests and integration tests and end-to-end tests. What kind of flaky tests are we talking about? All flavors? Because there's a lot of religious zealotry around, is this a unit test or is this an integration test? And if you mention database, are we even allowed to use databases in unit tests?
Yeah, so your question is a good one. And I don't think by the time our session is done, we'll have fully litigated the debate on what's a unit test and what's an integration test. But I can say in a number of the large open source systems that we've looked at, the test cases are more likely to become flaky or to have manifested flakiness in the past, the more that they are like integration tests and the less that they are like unit tests. So as test cases call more parts of the API, as the test cases take longer to run, as the test cases access more shared resources, or as they allocate more memory, it's statistically more likely that they're going to become flaky when they're frequently run in a continuous integration environment.
Interesting. And where did you go to gather all of this? Not just the data, but the anecdotes, because there's some anecdata here too, right? And you went to Stack Overflow. You were trying to figure out where to start to decide what your metrics were going to be.
Yeah, so thank you for asking about that. We did a couple of different things in order to get a sense of what types of flakiness are important to developers. And then also, how do developers actually fix the test flakiness that they find? So we did an open survey of developers and we systematically categorized all of the responses that they shared with us. And in addition, as you mentioned, Scott, we also took time to carefully search through all the posts that are on Stack Overflow for certain key terms, and then to carefully read and categorize all discussions on Stack Overflow that were related to flaky test cases, and then in particular related to the solutions that people on Stack Overflow proposed as a way to fix the flakiness.
Yeah, and it is worth reading the paper because I was fascinated by the what do you do part, the actions part, where because I saw myself in those survey results, and a lot of it is denial because people are saying, well, rerun it, which is the definition of a flaky test. Like, I don't know, this didn't work. I think I'll do it again. And we all know the definition of insanity is trying the same thing and expecting a different result. And then people would say quarantine, meaning denial, push it aside, pretend that that's a thing, mark it as a skip, or document it, which is another way of like pushing it, kicking the can down the road. I was surprised. Fortunately, most people acknowledge that repairing the test is the right answer, but I did see myself in a lot of the answers.
Yeah, I see myself in the answers as well. And I think it's worth having significant empathy for these developers because in many cases, the test itself may be flaky, but flaky because of some code that they don't own or some code that they're not an expert on. And additionally, the test cases that are flaky may also not be the test cases that they wrote or the members of their team wrote.
Hmm.
And so, in many cases, it is genuinely difficult to diagnose the source of failure and then to repair the test case and or repair the components in the system that are leading to the test flakiness.
Indeed. And you also pulled out one section I thought was particularly fun. You pulled out representative quotes for each of these sections, like it's often an organizational problem or this sucks. And we don't have time to address them all. So I appreciate your point around empathy. When you are looking at an overwhelming amount of tests, again, I worked in large enterprises for a long time. And if I've got thousands of tests and 10 or 15 are just consistently flaky, they're not regularly read. Therefore, I don't have the time or the emotional bandwidth to deal with them. So I'm going to keep retrying because I have bigger fish to fry. It's painful, but it's true.
Yeah, and you're making a good point because in many situations, the developers have features to ship. We all have features to ship. And if we have a reasonable confidence in the correctness of the system and a small number of flaky test cases, it may make sense at that point in time to take on some technical debt in order to ensure that you can ship a system and get some feedback on that system.
Indeed. And that brings me to a really good point that you make, which is there was a class of developer who looked at flaky tests as a silver lining. Why would a flaky test have utility?
So, first of all, I think there's a lot of reasons why test cases that are flaky have utility. And I think in my own development experience, they have definitely been a silver lining. I've had test cases that were flaky, but they were only flaky on a certain operating system, or they were only flaky in a certain CI environment, or they were only flaky at a certain time of day when they were run. And in all of those situations, I received, and I think developers would agree that they have received a truly wonderful reward because it gives them insights into the limitations of their system or assumptions that are undocumented or ways in which they can improve the testing process. And so, as a developer, if I get insights into how to improve my developer process or my testing process or the way my team works, I'm actually excited about that because it's an opportunity for me to learn and to improve.
Yes, a flaky test can be a gift for some. This episode of Hansel Minutes is brought to you by User Interviews. User Interviews connects researchers with quality participants. Participants earn money for their feedback on real products. There is high demand for software developers and engineers to provide feedback on products being created for developers. It's free to sign up, and most studies are less than an hour and pay over $60. Some studies pay several $100s for a one-on-one interview. You can share your opinions with top brands, Adobe, Intuit, Spotify, Amazon, and many more. Are you ready to earn extra income from sharing your expert opinion? Head over to userinterviews.com/hello to sign up and participate today. That's userinterviews.com/hello. I think your point about date time logic, though, hit hard as well. I've had times I worked in banking, and issues with what's the server time, what's the client time, how can we count? Is this UTC? I actually right now have a bug in my blog, which has been there for over 20 years. That is when we fall back, it can't deal with that because it can't imagine that time could go backwards. And my blog is down every year for 1 hour from 2 a.m. till 2 a.m. as it waits for, and I could get around to it, but it's a flaky, you know what I mean? It's a flaky production issue. It's hard to test. I know what's wrong, but it's only down for an hour. So I'm just calling it maintenance at this point. But date time logic will always get you.
Yeah, date time logic is really tricky, especially if the understanding of dates and time is different in the program under test compared to the test cases. In addition to issues related to dates and time, one of the things that we found in many of the large open source software systems that we looked at are issues that are related to timing, which I would say is different than a date or a time, but
Mm.
it's related to the test case calling the program under test, which is going to perform some asynchronous operation. The tester may not know how long that operation is going to take. And so instead of carefully waiting in the test cases themselves, we may put in hard coded waits for a fixed amount of time. And if the system under test is deployed to a faster machine or a slower machine during the testing process in CI, that can also lead to flaky test cases.
And that comes down to making assumptions about the space that you're operating that test in, whether it be there's your explicit inputs into your test, and then there's all of your implicit inputs, all of the contextual things that come around you, like the time zone, the locale that it's running in, the language locale, the time zone that it's running in, or the speed of the computer itself, the memory of the computer itself, whether or not it's got one kind of processor or another. A uh, you might have a large test array, all of which are x64, and then suddenly an ARM device shows up or an x86 device shows up, and you're only seeing your tests fail when one device in the pool that is heterogeneous pops in to fail your test. It sounds like you're saying you need to assert a lot of the assumptions that you're making about where that test is running. Those are those implicit inputs.
Yeah, I think you're exactly right. And oftentimes it's very difficult with the existing testing frameworks to encode these types of assertions that are about the execution environment. And certainly it is possible in different programming languages and testing frameworks to extract information about the CPU or the memory that's available or other aspects of the locale. But the APIs sometimes vary depending upon your operating system and your programming language. And so we can sometimes let those assumptions creep in to our test cases or into our configuration of the CI CD environment. And again, Scott, I think that's why this might be a silver lining, because now our test cases are surfacing these problems. And now we have a clear indicator that we've got to dig deeper and better express these environmental assumptions as assertions in our test suite.
Mm-hmm. So, in a space where these exist and they are flaky and I cannot detect them, how can I have some system warn me that there be dragons here? Can I use machine learning in some way, or am I looking at ASTs and applying static analysis to these problems?
Yeah, so your comment is a really good one. You mentioned something called an AST or an abstract syntax tree. You can look at things like an abstract syntax tree, which is intuitively just an intermediate representation of a program that's easy for our tools to study in an automated fashion. So we can build an AST to extract things about the number of assertions or the complexity of the program under test or the way in which the test cases execute. And we can use fast static analyses to flag up certain test cases as likely being flaky in the future. Now, another thing that we could do is to perform what's called a dynamic analysis. Now, it's important to note that if you analyze something like the abstract syntax tree, that does not require you or the program to run the program under test. In contrast, dynamic analysis is actually going to run the program and run the test suite and record information about when flakiness emerges and use those signals to warn the developer that for this system, when you go above a certain amount of memory in use, or you have more than a certain number of files open, then the test suite is more likely to become flaky.
Are you doing that by creating artificial constraints like memory constraints, starvation, thread starvation, or are you just running it a whole bunch of times in order to let chaos and entropy happen on its own?
Yeah, so your point is a really good one. Ultimately, we're doing both of the things that you've just described because certain types of flakiness tend to manifest themselves easily. And then you can use instrumentation to record these dynamic metrics and then allow those dynamic metrics to give you a clue as to when test cases are likely to become flaky. It's additionally helpful, though, to be able to perturb the execution environment in the way that you've described by like changing the thread scheduler or consuming portions of the CPU or introducing artificial memory overhead, because that can also help you to rapidly or more rapidly identify test flakiness.
Isn't that referred to as chaos testing? And is there a Venn diagram in which there is an intersection between flaky test detection and chaos testing?
Yeah, I think they overlap quite a bit because when you're doing chaos testing, you're trying to put your system into some kind of off normal execution environment that might more likely violate your execution assumptions. And when you can do that, you might find bugs in the program. But as you mentioned, Scott, it might also be a great way to surface flakiness in your test cases.
Interesting. Okay. This is making me think though that one could apply enough chaos that every test is a flaky test then. So then what have we learned?
Really good point. So I think it's some time during the testing and development environment, we have to agree on certain limiting assumptions about what is by and large an appropriate execution environment, because when we perturb the execution environment beyond some reasonable point, we can essentially say, okay, all bets are off. We don't know anything about the system's performance, or we don't know anything about its correctness. And additionally, we don't know things about the flakiness or effectiveness of the test suite.
Right. And then we have to ask ourselves, what is it that we're actually testing? Which I think it's kind of an interesting analogy to think about the difference between computer science and software engineering. We could test the correctness of the algorithm. We could apply mathematical proofs to say that this is a provably correct algorithm. But then when we start thinking about the practice of software engineering, we have to assume that the computer has power and that we didn't just yank a cable and we didn't just pull a RAM stick. I mean, there has to be an assumption that we can all agree on that this is a business system of some kind that is trying to solve a business problem, and it's not going to suddenly lose, 6 gigs of RAM suddenly in the middle of it. It's a tough needle to thread there.
Yeah, I agree. I think ultimately we need to make realistic testing assumptions so that we don't overinvest in a kind of testing that doesn't give us a confidence in the correctness and isn't likely to reveal meaningful defects in our system.
And that idea of that slider bar of how much effort to put into this reminds me of in the late '90s the arguments around code coverage and test coverage, and there was a very large group of people that were like, "Well, if you don't have 100% test coverage, then what are you doing?" But then it was like, "Well, but what's the hot path, and where are we spending most of our time, and what is the thing that's most likely to run, and what's my gut feeling of confidence?" What's your feeling on that? Is there anything there?
Yeah, so your question is a great one. I think the idea of code coverage is hotly debated. It was in the past and it continues to be debated now. I would say the following thing. First of all, in my judgment, low code coverage may be an indication of low test adequacy, and that may be a reasonable indicator that, yes, there are bugs lurking in my system. However, if I have high code coverage that's achieved by my test suite, that doesn't necessarily mean that my code has no bugs in it. And it doesn't necessarily mean that my test cases are perfectly adequate. So I like code coverage achieved by my test cases, because obviously, if my test cases don't cover a part of the program under test, I know for sure that I don't have a good shot at finding a bug in that part of my system. However, just because I have high code coverage doesn't mean that I actually wrote really good test cases that are helping me to establish a confidence in the correctness of my system.
I hope that you take this next sentence as the compliment it is intended. It is not in any way meant to be a backhanded compliment, but as someone who has not have a background in academia and is somewhat envious of those who were able to go and achieve PhDs, I went to a community college myself. You seem to be a very practical and pragmatic researcher. And sometimes when I interact with people at this level, I feel that they are head in the cloud academics, and you seem to be very much feet on the ground academics. How do you find that balance? Because you're really doing helpful practitioner work here.
So I would say that overall, my great joy as a researcher is to be able to identify challenges that developers in industry and developers on open source projects are facing, and then to think about ways in which I can use my knowledge and skills to create research prototypes that will help them to be more productive as programmers. So in the end, my goal is to help people. I want to be able to develop research ideas and research prototypes that can be most effective and helpful to the people who are developing software. And in that situation, Scott, I would say it's a big win for me. It's a win for the community. And additionally, it's a great sense of satisfaction for the students with whom I'm collaborating, because they also have a shared sense of accomplishment when they know that they've solved a problem that people care about.
That's fantastic. Well, I appreciate that, and I'm sure that the folks who are listening appreciate it as well. Where should we go next as the practitioners who are listening? That we can read your papers, we can look at your GitHub, but what can I do to put this kind of knowledge into practice today and maybe, in a year when research prototypes turn into products?
So the first thing that I would say is that I hope that software developers will become more aware of flaky test cases in their system. I hope they'll also take simple steps towards avoiding the introduction of test flakiness. As an example, one thing that I try to do is to always run my test suite in CI in a random ordering, because that helps me to avoid flaky test cases that are dependent on order. I think also it's worth thinking about the processes that we can put in place in our development organization that can avoid flakiness being introduced in the first place, to identify flakiness as a serious challenge, and to be willing to identify and then devote developer time and resources to avoiding the introduction of this type of serious technical debt. Also, I would love to give a challenge to all of the developers who are listening. If you have flaky test case problems, I would love for you to send me an email or DM me on Twitter, because I would be delighted to hear from you. If there are ways in which you can share the challenges that you're facing, I would love to learn more about those things, because ultimately my colleagues and students and I would be delighted to partner with you to better develop new automated techniques for detecting and repairing flaky test cases.
Fantastic. Well, thank you so much for hanging out with me today.
Thank you, Scott. I have to say, I'm a big fan of your podcast, and it has really been a great honor for me to appear and chat with you today. Thank you so much.
That's very kind. We've been chatting with Dr. Gregory Kapfhammer. He's an associate professor at the Department of Computer Science at Allegheny College. This has been another episode of Hansel Minutes, and we'll see you again next week.